friends, I am Nikhil Pitale, working as an assistant professor in civil engineering department at GH Raisoni College of Engineering, Nagpur. Today we will be dealing with the subject, or we shall see the overview of subject known as pavement design. Now, what is pavement design? Pavement design deals with, or it comes with, the subject known as transportation engineering, where we study how to design the various pavements, their materials, their properties and various tests involved. Now, basically a pavement structure is the one which carries the vehicular load and transfers the load safely onto the subgrade on which the pavement stands. If I try to classify the pavement design, I can classify it in two parts. One is flexible pavement and another one is rigid pavement. Now, flexible pavement consists of number of layers starting from subgrade, subbase, base and wearing course. The topmost layer being the wearing course. We will see in the diagram. This is subgrade, the lowermost layer, subgrade. Then subbase, then base, and the topmost layer is wearing course. As you can see, the flexible pavement consists of subgrade, subbase, base and wearing course. So, it is a layered structure. Now, if I talk about the load transfer in flexible pavement, it is grain to grain transfer. Grain to grain transfer, since these layers, these base course, subbase and subgrade, these layers consist of various materials. So, therefore, when the load passes on wearing course, when the load passes or the vehicular traffic passes on the wearing course, it transfers the loads to the base with the grain to grain transfer, again to the subbase and to the subgrade. Now, if I try to draw, suppose this is our wheel and layer beneath this contains some material. So, when the load is coming on this layer, the load is getting transferred from this grain to grain like this. Whereas in rigid pavement, the pavement is constructed directly on the subgrade. If I draw the diagram, this is the subgrade and there will be directly the pavement constructed. Let us say this is CC pavement or cement concrete pavement. So, as you can see, we can construct directly the cement concrete pavement on subgrade. The load is getting transferred or load is taken by this cement concrete pavement. It transfers through the plate theory. It obeys the plate theory. Let us say this is rigid pavement and a load is getting transferred to the plate theory. So, this is the basic difference between flexible pavement and rigid pavement. Of course, also we can construct the cement concrete, the rigid pavement on base also. After subgrade, we can construct the base, and on that base we can construct directly the cement concrete pavement or the slab. We can call it as a slab. Next, let us see what are the various analytical methods available to analyze the flexible pavement and to analyze the rigid pavement. First, we shall see methods to analyze the flexible pavement. Now, there are n number of methods available which are basically comes from the geotechnical engineering. The first method, and also these are approximate methods. First, group index method, or simply I can say GI method. Now, in this GI method, there is a formula of GI. There is a number. Greater the GI number, greater the GI, poorer is the quality. Okay. Greater the GI, with the help of a GI method formula, we will calculate one number, and based on that number, if our number is greater, then we will be classifying the soil or the subgrade as poor quality. Next, very common method, or I can say very good method, called as CBR method, or called as California bearing ratio method. Now, in this California bearing ratio method, what happens is we test the material on California bearing ratio apparatus, then we plot a graph, based on California bearing ratio, then we plot a graph between load and penetration. We will plot that results between load and penetration, load being on y-axis, penetration being on x-axis. So, basically we should get a curve like this, but if sometimes it happens that there is a concavity downwards in this curve, so that means there is a correction, there will be a correction in this method. So, correction applied can be simply draw a tangent from this concavity, extend this tangent onto the x-axis, then measure the distance from the 0 to the line where it cuts the x-axis, and basically what we do, the CBR formula is we calculate the CBR, California bearing ratio value, at 2.5 mm penetration and CBR value at 5 mm penetration. So if our curve gives correction like this, then we will have to add this correction into our subsequent load value and penetration value, and then we will have to calculate CBR or California bearing ratio at 2.5 mm and 5 mm respectively. So out of these two values, we have to consider the CBR value, which is obtaining at 2.5 mm penetration, 2.5 mm penetration. If the 2.5 mm penetration value is less, then we will have to again repeat the test. The third method we can use layered theory concept. Now in this layered theory concept, what we assume is our flexible pavement, we assume it as only having two layers. It is called as two layer theory. I can again write down here two layer theory, and I can assume the whole layers, I can assume these flexible pavement layers as three layers, or therefore I can write three layer theory. So by assuming two layer theory concept, I can calculate the various thicknesses of the flexible pavement. Also I can calculate with the help of three layer theory concept. Now these are the outline methods to analyze the flexible pavement. Now we shall see what are the methods available for rigid pavement. So basically, first of all, we have to see what are the points on the rigid pavement that should be considered for analysis. So the analysis here means we calculate stresses. So where do we calculate stresses is now if this is my rigid pavement, we calculate the stresses at interior, I'm showing it with I, small I, at edge of the pavement and at the corner of the pavement. Let us say I write here sigma I, that is stress at interior. Sigma E, stress at edge of the pavement. This is my pavement. I am calculating my stresses at interior of the section, at edge of the section, at the corner of the section. The major part or the influential stresses that occur, they occur on the corner portion of the rigid pavement. Now this is my rigid pavement, that means it is a cement concrete slab. Sigma I, sigma E and sigma C. Let us say this is stress at corner region. So basically, as per IRC 58, now this is a code for analysis and design of rigid pavements. It is a code of practice which is given by Indian Road Congress, IRC 58, and we analyze with the help of this code. So all these things are given in IRC 58. So what do? We analyze with interior stress by calculating stress at edge and by calculating stress at corner region. So out of which we will see also one more thing. Also we will consider temperature stresses. So let us say I show it as T sigma I, T sigma C, T sigma E. So T stands for temperature, sigma I, sigma C, sigma E, T sigma I, the temperature stresses at interior. So these are the methods available to analyze our rigid pavement. So friends, this was the introductory part of pavement design, and in next lecture we shall see the various methods and various designs. Thank you.